So now everything has, yeah.
Well, I mean, let's say like
All right, let's get started. You guys ready? Here we go. Week 13. Week 12 just ending. Everybody's handing in their homework, right? So here we go. After today, which is the 6th, we've got next week, the 11th and 13th, finishing week 13 and starting week 14. Then Tuesday the 18th is your last lecture. What's going to happen on the 18th is I'm hopefully going to have prepared a list of items that I know will not be on the final exam that I will go over on that last lecture on the 18th. Did we hear that? So you have something to look forward to. So that will help you know what not to study at least. Take some things out of the equation. Go ahead, Albie.
Can you get a list of items that will be on the exam?
No, but I did post, everybody notice I posted the practice problems that I did look at each one of them to make sure they were related to what we're doing, if that makes sense. There's a lot of them on there from week 5 all the way to 14, except for the pivot tables. There were no real practice problems for pivot tables. Will pivot tables be on the exam? Who knows? I have no idea. I haven't even started writing it yet. All I know is my goal is to have about twice as many questions as you would usually see on a quiz, and twice as much time as you would usually get for a quiz. My goal is to have about 55 to 60% of the information, all new material from after the second quiz to the end, and the other 40 to 45% be old material from the second quiz going backwards, but focusing on the most important subjects going from the second quiz backwards. I'm not going to go deep into obscure items. The more popular items that I think are the more important items. So that should help you at least focus on which items from the past. From the future, you know, it could be anything after quiz 2. And we had several weeks of subjects. But what's nice is this homework assignment you just handed in probably was not that hard. And I'm guessing because there was 4 problems times 2 parts for each problem, that it probably took most of you less than an hour, but maybe more than a half hour. Does that sound correct? For most people? And I was hoping somebody would say more than an hour though.
Just be like, yeah.
Yeah? Thank you. Making me feel good. I appreciate it. I'm an old man. I can always use it. So, what's different about this new chapter? Well, hang on. Before I get to the new chapter, heck with that. Let's talk about the homework you just team. Now, you thought week 11 and 12 were easy. Let me make sure you understand something. Week 11 was all about the mean and the standard error of the mean, right? And you had your A's where you do it manually using norm S to finish it off, and B's where you have your normal distribution. In week 12, it was all about proportions, but it was designed the exact same way. You did it manually, got your Z, used norm S, and used the normal distribution then after that. This week, I designed it the exact same way. Your A's are going to be doing it manually, and your B's are going to be using normal distribution again, but the difference is, I want to make sure everybody hears this. This week's homework and in-class assignment on Tuesday is all about in between 2 numbers now. Not just what's the probability of a number or less or a number or more. What's the probability between 2 numbers somewhere on that number line? That's the difference. Now, once I tell you this piece, this is the piece of the puzzle that you can literally do your homework after I say these words. This is all you need to know. Are you ready? Here's a bell curve. Here's 72% right in the center. If I asked you to find the probability of any 2 numbers that are within 3 standard deviations of this 0.72 on this number line, they could be both on the left, both on the right, on either side. If I ask you to find the probability of 2 numbers, the key is to find the probability of one number in one direction, find the probability of the second number in the same direction, subtract the smaller number from the bigger number, and the difference is the probability between them. Let me say that again. That's all you need to know, and you're done. I could walk out of here. You can do your homework. Ready? Because this homework is no different than the last 2 weeks you just did, except for this time, you're doing everything twice. Because you've got to find the probability of one number, find the probability of another number, then subtract those 2 answers. That's how you find the probability between them. It's that easy. Should we go home? Or just go to lunch? I'm Alex. You raised your hand first. Lunch on you? We have to sell your car to get that. There's a lot of us here. I'll make an offer of that. It's probably a 4-cylinder type, great gas mileage, but no turbo, so you can't get out of an accident. All right, that's it. That's all you gotta do. But today, we're gonna focus on the proportion part, so you can get that one down. Then on Tuesday, we're gonna focus on the mean with the standard deviation part, and then your homework will be easy. You probably even less than. Here's the other part of your homework. Let's get into it. Matter of fact, let's look at it. Here's week 13, but this time there's 2 parts to your homework. References. Okay, this is the best homework assignment for all the non-numbers people. They do great with the references. I want to make sure you understand what those are in a minute. And then the written Excel part, this is the part I'm talking about that's just like the last 2 weeks, where your A's are doing it manually and your B's are using normal distribution, okay? Almost just like it. Here's the weird part of this week's homework called references. There are 23 subjects on these pages, and all I'm asking you to do, now I want to make sure everybody hears this because someone's going to hand in definitions. I'm not even asking you to define these. I'm asking you to look on any of the items I've posted on Canvas and to write down where you can find the information you need for that subject. And then after you're done, take a picture of it and be ready to use it for the final exam. Let me repeat that. I want you to look at either the PowerPoints or your textbook or the homework or whatever items that are on Canvas and plus your book, and write down for every subject where you're going to look for that subject. For example, I don't know where cross-sectional data set is, but let's say it's on chapter 4, PowerPoint slide 32. That's what I would write on there. Chapter 4, PowerPoint slide 32. Or if it's in the book, I'd put chapter 4, or no, I'd put textbook page 134 middle. Or something that will be fast for you to find where to find that subject while you're taking your exam. Does everybody understand what I'm trying to help you with? A lot of these subjects happen to be the subjects that a lot of the multiple choice come from. And so when you read a multiple choice and realize what the subject is, and you want to quickly look about that subject, this is where this sheet will come in. It will take you right to where you need to go. So look at all these. Hang on. Look at who prepares you for final. Yeah, oh yes, sure. Yeah, some do those study guide, BS stuff, and those reviews. I'm having you put the work in to prepare. I don't know what I'm saying. I'm just having fun now. We're towards the end. It's time to have fun. Cross-sectional, time series, data classes. Do you remember data classes? Like between 50 and 60, between 60 and 70, data classes. Do you remember how we used to make classes? And that's going back a long ways on that spreadsheet. Mean, median, mode, standard deviation, range, interquartile range. We haven't seen that since way back. But if you remember, interquartile range was the range between the first and third quartile, the middle of the data. So find that slide or find that page number, every one of these. You can't go wrong. Each one's worth 1 point towards your homework. If you leave it blank and don't put any reference, you lose the point. And if you put a reference, I'm not going to check it. I just hope you're taking this serious and preparing for the final and it's a real reference. What PowerPoint slide or what page number. And if you're really taking this serious, put both the PowerPoint slide and page number so you're really prepared in case one doesn't help you on the problem that you're looking at and the other one would. Graph skew. I briefly brought this up when we were talking about central limit theorem. Skew to the right, skew to the left. Graph outliers, central limit theorem. Large enough sample size creates a bell curve. Where are those slides that talk about what the minimal sample size has to be? That's what you want kind of there. Stratified sampling, cluster sampling, that's pretty recent. Histogram, percentile. Remember me highlighting the difference between a histogram and a bar graph? You might want to remember that. I don't know why. Percentile, outliers. I got outliers on there twice? Darn it. Oh, okay, graph outliers and outliers. I don't know. Darn it. It may be the same thing. Check that out. You may put the same reference there on that one. Statistical inference, that was recent. Subjective probability, complement rule, addition rule. Don't forget, some of these are called laws on the PowerPoints. Addition law and rule mean the same thing. Multiplication rule, and multiplication rule for independent events. You remember that? There they are. There's 23 of them. One could be a repeat. This won't take long. It's just a matter of, you guys know how to search PowerPoints. You can even do the keyword searching on a PowerPoint if you can't remember which chapter PowerPoint is from. All right. The other part of your homework now is this part. 1A, 1B, 2A, 2B, 3A, 3B, 4A, 4B. Only 4 problems this time because you got the references. A's and B's are just like the previous 2 homework assignments. A is all about you doing it manually with the norm S distribution, and the B's are all about you using norm distribution without the S in the whole equation. Everybody know what's expected, including the references. Got quiet here. All right, let's get started then. Oh, wait, one more thing. Almost forgot. I want to talk about this one more time because I'm starting to get, I know that you've got to be starting to say, what is it I think I need on the final to get a certain grade? Some of you are finally checking in with your counselors and going, what do you mean I have to get a C in this class? I didn't know that. What? So, here it is. Here's the spreadsheet. If you notice, by the way, this is posted, I have this on Blackboard, or not Blackboard, Canvas on the syllabus tab. And there it is at the top. This is the 3rd version because I keep updating it. And here's what it looks like. If you notice, I moved all the weights from H to G for everything we've completed so far. But if you go to the bottom here, if you notice, I didn't move the weights yet for things we haven't completed. Chapter 12 homework isn't graded yet. Haven't moved that one over. 13, and we're not even sure we're going to have a 14, week 14 homework. We don't even know if we're going to have one yet. I don't know when we would be able to hand it in. That's the problem with week 14. The only thing I'm coming up with is maybe assigning a small homework on Thursday of next week, a week from today, which is the start of week 14. And then when we come on Tuesday the 18th for that last lecture, we're handing in week 14's homework, even though we're going to learn a little bit more about week 14 that won't be part of the homework. So that's the only thing I can think of. Or we're going to have to cancel week 14's homework, take that 1.6667% and spread it out among all the other homework, so that a percent of each of the other homeworks from the past will have a little bit higher, a small portion of that increased percentage. Anybody have any opinions they want to throw out there about the homework? About week 14 homework? Do you wish you had one or wish you didn't have one? You wish you didn't have a homework assignment? Now I want to tell you, it won't interfere with preparing for the final exam because you got a whole week between the last lecture and the final exam. So it's not like the homework is still already be handed in on the 18th. Anyone else feel strongly about either, if it's a short homework assignment on the easiest subject of the semester, it may be a guarantee, maybe the only time we all get 100 on the homework, that 14th one. I don't know. All right, I'm just throwing that out there. Now, let's talk about this stuff. Over here on the right, participation. Here's what I did. I put together a hypothetical student. Are you ready? Look at the grades of this student. 100 on the homework, 100 on in-class, 95, 98, 100. 75 on the first quiz. So this hypothetical student didn't do so good on the first quiz, got a C. 98 on the homework, 99 on the next in-class, 109, a 75 on week 6 homework. This hypothetical student forgot about one homework assignment, handed it in a day late, got a 75. Obviously, they also made sure the answers were all correct before they handed it in to guarantee getting a 75 because the answers are already posted. 100, 196, second quiz, 72, did worse than the first quiz. 75 on the first quiz, 72 on the second quiz, 100, 100, 92, 98, 100, 100, and one more item, 98. What is this student's grade? Got a C and a C minus on the quizzes. What is this student's overall grade that you see in the highlighted box? Letter grade.
B.
What'd you say?
B.
B it is. The student had a C and a C minus on the 2 quizzes, but has a B in the class as of right now, not including these few items. Chapter 12 homework has no grade yet, so I don't have the percent over here. Chapter 13 homework, Chapter 13 in class, Chapter 14 homework, Chapter 14 in class, participation in the final exam. Now, hypothetically, let's pretend that you want to put some guesses in there for these other grades, so you can start putting grades in for the final exam to see what's the minimum you need on it to reach your goal. We're almost at that point. So what I did is I said, well, up here, where participation is, we're gonna have 25 lectures. Let me explain. There's 14 weeks of lectures, 2 lectures a week is 28. But we had quizzes on 2 of them, that takes us down to 26. And we started spring break early and took that Thursday off before spring break, that took us to 25. Anybody remember that? No one ever sent me a thank you card. I never got it. I know you don't know my address, and you never will. But 25. So you have to, don't forget to subtract 1/4 of a attendance for every time you're late, that you got caught late. Amen. So subtract that. So let's hypothetically say this hypothetical student was late. Is that Ayash back there? Let's pretend it's him, and he's late like 8, 10, 12 times, something crazy like that. So for, let's say 12, so that'd be the same as 4 absences, so we'll put 21. That's almost too many. That's not fair. That's not norm. Hang on, let's put something better. You ready? Let's just go with 3 absences. So 25 minus 3, so they were there for 22 out of 25. Now, real quick, I'm gonna click on how participation is scored. It's however many attended out of 25 times 50% of your participation is attendance. Then our 6, what is that? Helping others, whatever that grade is 15% of your participation. Our 7, that's speaking up, whatever that grade is 15% of your participation. Our 8, that's emails, not handing anything in on 2 separate days, saying hi, I don't know, or asking a question, who knows. 2 emails, that is 10% of your participation grade. And then doing the evaluation completion and send me that little screenshot that you completed it, that's 10% of your participation. So let me keep going here. So you can see how that grade's calculated. Helping others, the grades for helping others and speaking up are almost all between 80 and 95, unless you're some kind of shiny marble for some reason. You get something above a 95. So I'm just gonna throw 87s in for everyone. 87 for this hypothetical, there you go. Just to be realistic. Yes, this person did 2 emails because they're not a fool. How easy is it to do 2 emails on 2 different days, not with nothing attached, just asking a question or even saying, hey, I got gas today, it was $3.40, something like that. Here we go, 2. There we go. Now, evaluation completion. It's open. I've only gotten 10 emails so far out of 65 that said they completed it, but I looked and there's more than 10 that completed it. So some of you who completed it, go back. Don't forget, it's just that page that lists your classes and it says completed and the date you completed it. Just take a screenshot or a picture of that with your phone and send it to me, and that's how you get this 1. Now, I want to tell you, even if you accidentally forget to do this, you're probably still going to get something like 0.33 out of 1, because what I do is I look at how many people did it and how many people didn't send me in anything and how many people didn't fill it out, and I split that up between everybody that's left, because I have no idea who did it and who didn't do it when they don't send me anything. So sometimes that turns out to be 0.33 if you're somebody who didn't even do it. You still may even get credit for it. Well, let's pretend you did do it. Let's turn that to a 1. Here we go. The participation grade for this student who was late 6 times, got an 87 and 87 on the 2 little parts I can judge on. Did both emails and handed in the evaluation, got a 90. That 90 automatically went down here, but look at their grade. Their grade has not changed, it's still a B, because this is now when you take that 5% and move it into this column, now that there's a grade there. So here we go, when I do this, we're gonna see participation's at 90, so it should raise that 83.8 up to about, I'm gonna guess about 85. It's still a B though, doesn't even change the grade, but let's take a look. 84.27, still a B, but it went up a little. As you can see, participation, no matter what score I give you up here on my judgment, helping others and speaking up, whatever score I give you here, as you can tell, is not gonna have an effect on your grade at all. I mean, you would have to be right on the exact line between 2 grades for my judgment to have any effect on your grade. So like I said, don't worry about how I feel about you. I said that at the beginning of the semester, because this is a non-biased type grading system that I have almost no effect on your grade. Let me finish this up now. This hypothetical student did week 12 homework, got 100 or a 95? 95, thank you, 95 on it. I gotta move the weight over. This is you now, you downloaded it, so you gotta move this weight over. Instead of typing it out, I'm just gonna drag it, there we go. So now that counted, that 95 took the grade up to 84.5. Next, this week 13 homework. You guys just looked at it, you saw how easy it is, except for you did all 23 references, even if one's a repeat, and you just say you got 100 on this one. All right, you with me still? So now, week 13 in class, next Tuesday, we'll move that over. Let's say you got 99 on that, because you know I'm going to look for anything I can to take a point off. Thank you. And then week 14 homework. This is the one I think everybody's going to get 100 on, because it's going to be short and simple maybe. And last but not least, on the last day of class, on the 18th, we're going to finish everything with an in-class assignment, and everybody's going to get 100, no, so 98. Now, here we go. Going into the final exam, what grade does this hypothetical student have? No, yeah, but what's the letter grade? B. What do you gotta have? I can't remember what a B plus is. 87, right? So that'd be 86.5. Look at the first digit to the right of the 85. It's a 6. So this would be considered an 86. I go one digit to the right where that ends up. If that's a 4, then that's an 85. But because it's a 6, that's an 86. Go ahead.
You looked at 25 and you looked at 25 and you got 0, it's not.
Oh yeah, exactly. Yeah, this is now we're at that step though. This is now, you know your grade going into the final. I am gonna do what he just said, move the 25% over, but I'm gonna throw a grade in there first before I do it, because it will take this down to, you know, who's gonna get a 0 on the exam? You're not showing up? Even if you don't show up, we'll still make arrangements to have you take it from prison. You know, I'll work it out with the prison guards, no problem. All right? I'll put up bail just to get you out to take the final. So then, I'm gonna throw a grade in there. Let's say this person who got a 75 on the first quiz, a 72 on the second quiz, gets a 70 on the final exam, doesn't change the grade yet because we didn't put the 25 here. Are you ready? What will that 85.6 go down to? 25% of the grade's a 70 on the final exam. Are you ready? This could have a big effect. They went to a B minus. They went from a B to a B minus. And they barely got a C minus on the exam. So as you can see, all that work from the homework and in-class assignments are still gonna keep you in a position to where this class is designed for everybody to get a C or above, unless you work hard at not getting that C and above, and which some are doing. And there's nothing I can do to stop it, no matter what I say in those first few weeks. Just try to, like, and I want to point something out. There are 7 zeros still for this section. There's more than 7 altogether, but for this section, there's 7. Which means you guys, some of you are not looking back at your grades and going, oh, I never did this assignment. And realizing you just gotta write the answers. The answers are posted. Take a picture, hand it in, and turn that 0 into a 40.
Can we get 100 on participation?
No. It's impossible. To get 100 on participation, is that what you just said?
Yeah.
Yeah, that's impossible.
Why?
Because I'm involved.
Ooh.
That means you'd have to be the person that gets 100 on helping others and 100 on speaking up?
Yeah.
Is that what you're trying to say?
Yeah.
Who are you describing, yourself?
Yes.
I'm just checking. Then maybe it is possible, I don't know. Is it? Wait a minute, you're saying you've never been absent, never been late once?
Yes.
Should I go check the record?
Yes.
Okay, never been late, never been absent. Have you already done both participation emails on 2 different days?
I sent you like 5 emails.
5, okay, so you got 2. And have you already completed the evaluation?
You sent it to me at 4 a.m.
Okay, real quick, let's see what happens. Raise your hand if he helped you during the semester on your in-class assignment. Oh, really? Oh, really? I didn't think that was gonna happen. Man, really? Did he? Because we all know he speaks up a lot. We all, I mean, I don't have to ask about that, but wow. What do you mean? That's a good thing. Who said what? Was that Grant or Matt? Was that Matt? Matt, was that you? No. Oh, Brian? Come on, who was it? What do you mean? Am I giving him too hard of a time, Matt? It's okay. Look, I can't affect your grade, man. What? I cannot affect your grade. So if you feel I'm giving him too hard of a time, let me know.
Oh, no, it's perfect.
Really?
Yeah.
Okay. Because I do like ripping on them.
Oh, yeah.
Okay, good. All right, just making sure. I didn't know you were getting as much joy out of it as I am.
Oh, it's funny.
Okay, I know. I've had fun with it too. That's all I got. You guys now know how to use this. Let's say this, and let's say this person. Caitlin, can I say this? Can I say this? Just pretend.
What? Sure, yeah.
Okay, let's put Caitlin. She's going, oh man, oh, I got all this stress. There's no way I want this B minus. I want a B. So she goes, what in the heck do I have to do on this final exam to get the B that I want, right? Right? What do we have to do? First of all, what does that have to be for her to get that B? What does that number have to be? What's the very lowest it can be for her to get the B? 82.5. 82.5, very good. Not 82.4, not 82.6. So I'm saying, could she still get a B in the class with a 75 on the exam? Yes or no? Before I hit enter. No, no, no. That's a 5-point increase on the exam, which is 25% of her grade. And this could be significant. She's got a B. That's all it took. It's possible. So if you're at that point to where you go, oh my God, I have a C minus, I'm gonna have to take this class over. Start throwing some different scores in, and maybe you may be shocked at what you really need to get that C in this class and not have to take this class over.
So you're going by the average of your first 2 exams?
What's the average of first week one?
No, I'm saying it's based off the average of your first 2 exams, if your grade goes up or not.
In a way,
It is?
because the first 2 quizzes you mean had such a big effect on your grade, right?
Yeah.
But even though this hypothetical student got a C and a C minus, they had a B still going in the class before the final because of all the homework, and they even had a 75 on one of the assignments. That's the whole point. These assignments that you guys are finding, oh, it took less than an hour. And yes, you had how many homework assignments? 14 of them. No, wait, there's 2 you didn't have to hand in, so 12, right? 12 homework assignments. In class though, we're gonna have all 14. We had one every week. I don't know, are you having in-class assignments that you work together like this every week in another class at all?
No.
Not at all? Oh. Well, the whole point I do it is because I want you to learn not just from me and not just from the book and the PowerPoints. I want you to learn from each other at the same time. And that was the whole concept behind the in-class assignments. Plus, the design was that everybody will get a good grade on it, and I hope everybody gets 100 on the in-class, because those are the things that will help you stay afloat even if you fall apart on one of the quizzes. That's the whole point of these in-class assignments, to help you stay afloat if you fall apart. All right, so let's get to the new stuff. I think I've bored you enough. Everybody got to realize how to use the spreadsheet, and does everybody agree that Ahmed gets 100 for participation? Are we all voting on that?
Yeah.
We're giving it to him?
99.
99, I like his philosophy. I like 98, because I'm gonna give each of you 2 one for just putting up with it. All right? So, there you go, an extra one, 98.
Where can I find it?
Is that fair?
Professor, where can I find it?
We're under syllabus. Go to the syllabus tab. It's at the top of the syllabus tab, that spreadsheet I posted. All right, here we go now. This is it. This is real stuff. Let me get my pen ready. We got work out of us. How are we doing on time? Is it lunchtime yet?
Yes.
Really? That's the most I ever got out of you. It had to do with food. Wow. Okay, here we go. We're going to focus on proportions, and what today's about is finding the probability between 2 proportions. This first one I'm going to show you is really easy because it's going to be, the 2 numbers are going to be the same distance from the center, which makes it really easy. But I then need to show you one where the numbers aren't the same distance from the center, so you can see how to do this no matter what. Here we go. Let's see. Oh wait, I forgot. We've got something fun today. So when we get bored a little later, let's jump into this, because this could be fun. If you keep an open mind, this could be fun. Did I mention fun? All right, make sure. And then don't forget, we got this z-test Excel equation that we got to get to also. Hopefully I won't forget. All right, so here's the deal. You remember you're the head of the college admissions. Do you remember you had to go to the meeting? Come on, help me out. You didn't have time to put all the applications in. How many did you sample? Can't hear you. How many? 30. Very good. You took a sample of 30 to go to the meeting with. What were one of the 2 subjects you had to present at this meeting? Come on, what was it? Average. what was it? SAT score, I believe, wasn't it? It's not even on that screen. What was the other thing you had to report?
Housing.
The housing. The percent that said yes or no on the housing question on the application. So the housing director can prepare the dorms, right? There were, how many did we accept out of the applications? We had 600 or 900? 900, so we had 900 incoming freshmen that we accepted and they committed. 900. We don't have all the information in the computer, but so we have to walk into this meeting with estimates. I want to focus on the proportion part. What percent of the applicants said yes? Because then whatever that percent is, multiplied times 900 should be the dorm director's goal to have set up, expecting that many students, new students. Now, and there's returning students also. It's just how many new students. So we're walking in that meeting with a sample of 30. Here's my question. I want to make sure you realize this. We walked in the meeting with, and we announced, I want you to remember this, hang on, where is it? Come on. We walked into that meeting and we announced, according to our sample of 30 applications of incoming freshmen, 68% said, yes, we want to live in student housing. The average SAT score was 997 we announced. We're going to talk more about that on Tuesday. Today, the 68% is what we walked in and announced. Now here's the deal. We took some risk because we're about to calculate what was the probability of us walking into that meeting with a number that ended up being within 5% of the actual number. Once we got all of them in there, it ended up being 72%. So how far were we off? 4%. I want to know what was the percent chance that we walked in there and we had a number that was within 5 below 72 or 5 above 72. That's a pretty good estimate. What kind of confidence do you want to have when you walk into a meeting like that? If you were the director of admissions, by the way, I used to be the assistant director of admissions back in 1988 at a college. So I've worked this admissions deal. So I know what this is all about. I went through all this. My question for you is though, when you're using statistics and you walk in a meeting, do you want to be 25% sure that what you're presenting is close to what is actual? Or do you want to be 50% sure? Do you want to be 70% sure? Do you want to be 90% sure? How sure do you want to be? How confident do you want to be that the number you're presenting to that housing director, 68%, is darn close to what it's going to turn out to be once you get all the applications in? How confident do you want to be? 90% confident. You don't want anyone to say, oh, how could you give us a number so far off? Right, you want to walk in and you want to say, I feel pretty confident this percent based on my sample. So we took a sample of 30. I want to show you how to determine how much confidence we had, how much risk we were taking. So I say we did a great job if we walked in either 5 below or 5 above the actual number that we didn't know at the time. So 5 above would be, I got it right here. So 5 above would be somewhere in here, 77%, and somewhere down here is 67%. I don't know where they land yet. We don't know the standard area yet. I'm just saying there they are. I want to know, look at the bell curve. We want that center to be, did you say 90? 90%. I actually be happy with 80% even. 75. I don't think we walked into that meeting with 75%. So we took some risk of hurting our reputation and causing confusion. And I want to tell you, when you use statistics and you do walk into a meeting and you do give a number that's far off of what actually happened, you need to communicate as quickly as possible the actual number and explain that it is slightly off and you need to prepare for more people or less students or whatever that situation may be. So here we go. Here's how we're going to do it. Again, the key to this week's homework and this week's lesson is you have to do every calculation twice. Find the probability for each number, then subtract the two. Now here's the deal. I could find the probability for 67% or more and 70%, 77% or more and subtract the two probabilities and I found the probability between them. Or I could find the probability for 67% or less, 77% or less, take those two probabilities, subtract them, and I found the probability between them. Either direction, the key is they have to both be in the same direction. Did everybody hear that? If you're going to calculate the probability of one number and another number to find the probability between them, you've got to calculate the probability in the same direction for both numbers, then subtract. You can't do one is greater than and one's less than. And it's much easier to just do both as less than and not have to do the one minus part. Just make them both less than. Since they both got to be in the same direction, you save a step on both of them. So that's what I have set up here. Here's your part A. The question is going to be, hey, we found out that 72% of incoming freshmen want to live in housing. What was the probability of us walking into that meeting with a sample of 30 and presenting a probability between 67 and 77%? That's the question. It's the question asking you between two numbers. Tuesday will be between two means. Today's between two proportions. But the concept is the exact same. So even though I'm not presenting means today, those of you who get this could literally do their homework tonight or while I'm talking even. Go ahead. I'll bring my grandma in to race you. You ready? So let's do it manually. 0.77 minus 72%. 72 is the given proportion, so we use it in the denominator. 0.72 times the opposite of 0.72, 1 minus, divided by 30, square root the whole thing. So, two people are still not getting the square root. On proportions, that square root's got to be the whole denominator, not just the top part. Take that square root all the way down. I'm looking around because I can't remember who the two people were left it off, but you got to go the whole thing. This ends up being 5% over 0.082. There's the standard error. This gives you a z of 0.61. Put the z into equals, norm S distribution, 0.61. I'm going to get that for me while I go on to the next one. Here's the next one now. We just did 67 or less. The next one, 0.67 minus 0.72. I'm just doing now, whoops, that was 77 or less. So I'm doing now the 67 or less. So that was 77. That's going to be a big percent over 50. Now I'm doing the one that's going to be less than 50. 0.67 minus 0.72 divided by 0.72 times 1 minus 0.72 over 30 square root. Look at, because I picked numbers that are exactly 5% above and 5% below, the numerator is the exact same thing. And we're using the exact same 72%, so the denominator is the exact same thing. 0.082, 0.082. The difference is that this one's negative 5% because it's less than the center. This one's positive 5% because it's 5% above the center. So it's going to be the exact same z. There it is, 0.61, but this one's negative. Positive 0.61, negative 0.61. Now the reason I'm pointing this out is because I don't know if it's on, you might have one homework problem where the two numbers are the exact same distance from the center, and you literally only need to do the calculation once, knowing the other calculation will be the exact same number but negative. And you can put that on there instead of showing me both calculations, saying here's the calculation once, the other one's the exact same distance below the mean, so it will have the same z but a negative. Save some work. Just put on there why you're not doing it. Because you did it. Equals norm S distribution negative 0.61. I'm gonna, you ready? Give me the positive one first. This is the, let me see, this one is to the right. Even if you get these mixed up, when you get these two percentages, you take the bigger one of the two minus the smaller one. If you do it the opposite way, you're gonna get a negative answer. The probability between two numbers is never negative. So you take the bigger probability minus the smaller probability. Go ahead, what's this one? 7291? 7291. Now, this negative one is 0.2709. 2709. Now you just take 0.7291 minus 0.2709 equals 0.45, 0.45, 81, 0.4581. Now, what did we just figure out? We just found the probability of us walking into that meeting with our sample results from 30 of presenting a probability within 5 above or 5 below the actual number that we need to report later when we get them all in there. We walked in with only 46% confidence. Matter of fact, odds were against us reporting a good number. So I call this luck. We walked in and we got lucky. We were only 4% off by luck. Odds were against us being that close. So what do I gotta do if I wanna do what a good manager would do and walk into that meeting with 75% confidence, or 80% confidence, or 90% confidence? What do I have to do? What would have to change in this whole concept that we did as a director?
Take more than 30.
More than 30. That's the key. We should have used a sample size bigger than 30. That's it. That's the answer. Now, if you wanna walk into that meeting with better confidence than just 46%, this may be a situation where you wanna have more than 30 in the sample size. Let's do this real quick. Let's just say the problem says, what should we, give me a number you wanna increase sample size to.
150.
That's big. 150? Let's do it. Here we go. All it changes is this 30 turns into, wait, I'm sorry, I'm gonna leave the 30. I'm crossing it out, make it 150 below. I'm crossing this out, and I'm crossing that out. So this one here, change that 30 to 150, cross that out, cross that out. Now I only have to do this once because we're still exactly 5% above, 5% below. So once I calculate it on this side, the negative is gonna be the exact opposite. So I only have to do it once. Is anybody helping me with this? You are? If you're the only one, no one else wants to even get involved? No way? Seriously? Darn. Oh wait, I gotta cross this out, 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 cross this out. So now we're going to 150. Just tell me the denominator. 0.72 times 0.28 divided by 150 square root. All I need is that number right there. What? 0.06? You got the same thing?
I got the total one.
Okay, but you don't remember what this was? Okay, let me ask this then. What's 0.05 divided by 0.06? And let's see if it's the same thing he has.
I got 0.03.
1.3.
This is not 0.06?
I think there you got 0.034.
This is 0.34?
I got 0.0366.
That's what I got.
Point zero
That's the final.
4,
No, 366.
thank you. 0.0366.
Yeah, you just want to.
That's our new denominator, right?
Yeah.
So this is 0.0366. Now, 0.05 divided by, this is now gonna be 1 point what?
36.
36?
38.
38? 3638?
39.
39, okay. So now, norm S distribution is gonna be 1.3639. And over here, we know this is gonna be negative 1.3639, right? This is gonna be negative 1.3639. Anybody gonna take a picture of this? Just checking. And now, our two probabilities, now that we increase the sample size to 150, this probability is gonna be high, like 90%, right? Norm S distribution 1.3639. I'm in hit or
I got something different. 0.05 divided by 0.0366 is 1.366.
1.36 what?
61.
61 instead of 39. I'm gonna go, watch what I'm gonna do. I'm gonna put a 5 there. Look at that. I'm just throwing a wrench in it. There we go. How's that? We're gonna be so darn close it doesn't matter. So now, change that to a 5. Just change that. I'm right between the two of you. All right. So now, what's this probability? Seriously? Really? Look at everything shut down. I haven't touched these in so long.
It's 0.91.
Yeah, it's gonna be
Oh,
high.
you're not giving me
0.91 what? Just round it. 0.91 or 0.92?
I got 0.938.
0.9138? Okay, so this is 0.91, and this one over here, don't round like I'm doing right now, by the way. This one over here is point what? Negative 1.365.
0.009.
09.09, ready? 91% minus 9% is 82%. We could have walked in that meeting with 82% confidence that we're gonna report a number within 5 above or 5 below the actual amount if we increase our sample size from 30 to 150. That's a big step. Going into the meeting from 46% all the way up to 82%, I would feel a lot better about. But look at the time it takes to do a sample size of 150 compared to 30, running the random numbers, pulling them out, finding the average. But it'd be worth it to have that confidence. Everybody see how to find the probability between two numbers? We're gonna do one more, and then we have our fun thing. Yes. 0.91 minus 0.09 equals 0.82. How's that? Everybody excited that last step? 91% from the one, 9% from the other, subtract the two, leaves you with 0.82, 82%. That's how you find the probability between them. Okay, we got one more. We're going to page 256. Unless you want to go straight to the fun thing.
I like that.
What? Really? Let's vote. Raise your hand if you want to see one more. Anybody want to see one more example? Really, there's only 1, 2, 3, 4 of you, 5, 6 that want to see one more. 7, 8. Oh, you want to see it? Okay, let's go. Let's go. Since there's only 7 of you that want to see this, we'll go kind of fast. 7 people that want to see more. Here we go. Huh? Hey! Dakota says you guys didn't hear me. Raise your hand if you want to see one more. Okay, so now we got 9. Okay, you got 2 more people. So 2 people didn't hear me. I think there's 2 people changed their mind. I think they heard it all along. All right, can we see this? Look at that. Hang on a minute. Okay, ready? Number 22, we're going to do D. 22 says, consider a population proportion of 12%. Here's the given proportion, 12%. See it on the right? Says, consider a population proportion of 12%. D, if the sampling distribution of the sample proportion is approximately normal with a sample size of 50, then calculate the probability of the sample proportions between 10 and 12%. Now look, everybody, one of those 2 numbers happens to be 12%. The given proportion is 12%. Let me make sure you see this on a number line so you can answer this for me. One of the numbers is 12%, 0.12. The other one is 0.10, 10%. And the given proportion is 12%. So if I'm saying there's no reason, look at this right here. This 12% right there. There's no reason to calculate this. There's no reason to calculate it. It lands right where the given proportion is. What is the probability of 12% or less? 50%. There's one of them right there. All we got to do is this one right here. And here it is. 10%. What's the probability of 10% or less when we're given 12%? 12, 12 divided by 50 is our sample size. Negative 2% over 0.04596. Here's our Z, negative 0.43516. Put it into the norm S distribution and give me a probability. Equals norm S distribution negative 0.43516.
0.3317.
0.3317.
317.
There's the probability for 10% or less. The other one is 12%. So watch. I'm just going to put 15% right above it. I don't need to calculate the 12%. It lands right on the given proportion. So we know it's 50%. So 50% minus 33% leaves us with what? 27%? There's 27% chance of getting between 10 and 12%. Now, I said, what if though it said between 10 and 13%? We got the 10%. We know that's 0.3317. All we got to do now is the 13% or less, and then subtract the 2. Go ahead.
17.
What? This is 17? My bad. Thank you. 17%. Thank you. Sorry. 50 minus 33, 17. Here we go. Now, the proportion being asked about is what's the probability of being between 10 and 13% instead of 10 and 12? 13 minus 12 is 1%. That takes us to a Z of 0.21756. Normal distribution of 0.21756. Now, we're bringing this down here. This is going to be, since it's on the right side, it's going to be bigger than 0.33. So we're going to be subtracting 0.3317. What is the probability for norm S distribution 0.21758? 58? 61. 58, 61. 0.5861. Subtract these. 33, 43, 53, that's 25, a little more than 25%, does that sound right? 0.25 something something, right? Right? 0.2544? 0.2544% chance of the numbers being between 10 and 13%. Now I want to make sure you saw this. 10 was to the left, 13 though was only one to the right, so we found the probability of this area right here, a little more to the left than there is to the right, is what we just found. My question for you is now, do you see how easy it is to find the probability between two proportions, because it's exactly like the homework you just handed in, but you gotta do everything twice. Everybody get it? Now, B, part B. I can tell by the amount of time that's left. Let's do it. Let's do it. Let's do part B. We got time. Boy, we haven't got room though. Okay, I'm erasing this. Are you ready? Let's go back to the original problem right here. What's the probability of our sample of our 30, we're going to look at the 30, the 0.61 and the negative 0.61. What's the probability of us walking into that meeting and reporting a probability of students, a proportion of students that said, yes, I want to live in housing, being within 5 above or 5 below that 72%? Here it is. You ready? Equals norm dot distribution. You don't have to do the dot, I just do it. Ready? 0.77, comma, 0.72, comma, SQRT, parenthesis, 0.72, asterisk, parenthesis, 1 minus 0.72, parenthesis, divided by 30, parenthesis, comma, 1, parenthesis. So there it is for the 77%. Now watch, no space, minus NORM dot DIST. And everything's the exact same except for that first number. That turns into 0.67 on this one here. Everything else is the same. You have one normal distribution equation where the larger percentage is going to be minus the other normal distribution equation where the smaller percentage would be. But here we go. I'm going to tell you that I'm going to accept another way of doing what I just did. If you're somebody who doesn't want to put this long equation, one minus the other, you can go ahead and write one equation and get the result, write the other equation, get the result, and then show that you subtracted both results from each other. I'll take that too instead of one long equation. That's acceptable for B's.
So like, for example, it could be like A5 minus A6, like where the lines are in Excel, and then that would equal the answer.
I'm almost with you.
So it's like the first norm distribution and then the second normal distribution.
Oh, yeah. Oh, I see. You mean a line, rows on the spreadsheet? You're writing it down on paper anyway. So it's up, yeah, you could do them on two, you could put that equation anywhere you want and that equation anywhere you want on a spreadsheet because you're not going to hand in the spreadsheet.
Okay.
But you're going to write, you can write down one equation, get the answer. The other equation now is somewhere else on the spreadsheet. You can put that answer and then subtract those two answers on your whatever you're handing in. Oh, hang on, no, I went right over you. You didn't see it.
It didn't work in the same.
Yeah, they will. It will work in one cell all the way across, as long as you don't put any space here and you have the parentheses all the way. Is that what you're saying is not working? You're saying it's not working, right? Okay, you got $1? What's $1? Are you kidding me? Why are you guys so cheap? We're never going to get to this Z-test. We're never going to get to Z-test. I'm going to have to now put it off until when? When do we get together again? Tuesday. 2024? Oh, Tuesday. Hang on. Equals NORM dot DIST, parenthesis, 0.77, comma, 0.72. What I blow? Oh, you can't see it. That's what's going on. Yeah, darn it. Hang on, almost there. There's a pen in the way. Okay, here's where I'm at. Equals norm dot distribution 0.77, 0.72, comma, SQRT, parentheses, 0.72, asterisk, parenthesis, 1 minus 0.72, parenthesis, divided by 30, parenthesis, comma, 1, parenthesis, ready? Minus NORM dot DIST, parenthesis, what's the other number? 67? 67? 0.67, comma, 0.72, comma, here we go, SQRT, parentheses, 0.72. Look, I'm going really fast, so I'm probably gonna make a mistake, but I'm still willing to put money on it if he's ready. What?
You can just
You
copy
gotta
paste.
put one minus.
What?
You can just copy paste. And change
Yeah, I guess I could have. I've got the 1 minus, thank you. That's what I get for talking while I'm doing this. Minus 0.72, parentheses, divided by 30, parentheses, comma, 1, parentheses. If I did this right, we should get 0.4581 or darn close to it, right? Right? All one equation. You ready? 0.4581. Bam. Let's have a good lunch. Wait, I'm sorry, we still got fun ahead of us. Don't leave yet. Unless you don't want to have fun. If you don't want to have fun, you can leave. Okay, let's go. You ready? You gotta get a small piece of scratch.